In today's lesson, we're going to be working more with systems of equations and seeing what types of solutions there are. In the last lesson, we saw that when we graph two lines that intersected at one spot, meaning that there's one solution, but that might not always be the case. All right, so in these equations, we're going to look and see if they intersect or if they don't intersect. Now, in the first one, we have y equals x minus 6 and y equals negative 3x plus 6. So again, they're both in slope-intercept form, meaning that I can graph them. So in the first one, remember that invisible 1 is in front of the x. So my rise over run is up 1 over 1. And my starting point is at 0, negative 6. So I'm going to graph this 1, 2, 3, 4, 5, 6, and go up 1 over 1 to make my straight line. And again, it's important to go in the other direction as well. Now the other line, it's in our slope-intercept form. Our slope is negative 3, so you go down 3 over 1. And you start at 0, positive 6. 1, 2, 3, 4, 5, 6. Down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And I can't go in the other direction because there's not enough room on the grid. So they intersect at the point 3, negative 3. So that is our solution. So in this case, we have one solution. Okay, 3, negative 3. All right, so that's just like the problems we've done before. All right, let's look at number 4. Now, with this one's not necessarily in slope-intercept form yet. We have parentheses. Remember, when we have parentheses, we have to distribute. So 1/2 times 6x is 3x. Half of 6 is 3. 1/2 of negative 8 is negative 4. Now it's in slope-intercept form. I start at negative 4. And I go up 3 over 1, since my slope is 3. So up 3 over 1, up 3 over 1, up 3 over 1. And again, the other direction, down 3 to the left 1 to make a straight line. Not so straight, but good enough. Now the other equation, notice it's the same exact thing. We have my slope is 3, my y-intercept is negative 4, so it's going to be the same exact line right on top of the other one. Now, when that's the case, when you have two lines on top of each other, you have infinite solutions. That means every single point intersects and is in common with the system of the equations. All right, let's look at number 6. Again, my first equation is not in slope-intercept form yet because of the parentheses. So 1/2 times 6 is 3x. 1/2 times negative 10 is negative 5. So I start at negative 5 and go up 3 over 1. Now in the other equation, again, 3x is in y equals mx plus b, but we usually don't put the plus 0 there, so we start at the origin. Okay, because 0 is our origin. And again, we go up 3 to the left 1. So up 3 to the right 1, I should say. Sorry, up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. Same in the other direction. Now, if you notice with these two lines, they never intersect. Reason being they never intersect is because they have the same slope. So if you have two lines with the same slope but different intercepts, they are never going to intersect. And when they never intersect, there is no solution. Okay, since they will never intersect, this gap will always be there. All right, so those are the three different types of scenarios we could have in a system of equations. We could have one solution. We could, like up here, where the two lines intersect. We could have infinite solutions where the two lines are on top of each other. And we could have no solutions where you have two lines that never intersect but have different y-intercepts. All right, so that's it for today's lesson. Work through these problems. If you have questions, let me know in class.